Next question is question number 34. In this question, it is given that the OPAMP is ideal and the transistor has a VVE value of 0.6 volt. Its beta value is 150. Then we have to find out what is the type of feedback here, whether it is positive feedback or negative feedback, and what is the voltage here. Let us start by assuming the transistor is off. Once the transistor is off, there is no negative feedback, hence the OPAMP will be acting as a comparator. So suppose the transistor is off, in that case the OPAMP will act as a comparator, and if the transistor is off, then there is no current flowing through the transistor, so IC or IE value will be equal to 0, and once that is 0, this 10 voltage will directly appear across non-inverting terminal and this 5 voltage appear across inverting terminal. So if V plus, that is here the voltage, that is V plus is 10 volt and V minus is 5 volt, then the output voltage will be plus V sat, as it is acting as a comparator. Once this voltage is plus V sat, to switch on the transistor we require only 0.6 volt, but this voltage is much greater than 0.6 volts, so the transistor will definitely on, and once the transistor will on, then it will provide negative feedback path through the resistance RE. Hence the OPAMP will no more act as a comparator, it will be acting as an amplifier. So once the V is equal to plus V sat, then the transistor will be on. If the transistor will be on, there will be a negative feedback through 1.4 kilo ohm resistor, and because of the negative feedback, the OPAMP will operate in the linear region. That is, it will be acting as an amplifier. It will no more saturate. So the virtual ground concept will apply here, because ideal OPAMP is given. That means the gain is infinity. So V plus will be same as the V minus. Hence the virtual ground concept come into play. So because of the virtual ground concept, V plus voltage will be equal to V minus voltage, that is 5 volt. Let IC is the current flowing through this 5 kilo ohm resistor. There won't be any current through the non-inverting terminal of the OPAMP because of the high input impedance. So IC value will be equal to 10 minus 5 divided by 5, which will be equal to 1 milliampere. As beta value is very large, we can say that IE is very close to 1 milliampere. Then we can find out what is the voltage VE. VE will be equal to 1.4 volt. So as the transistor is on, this VV is equal to 0.6 volt. So this voltage will be equal to sum of VE plus 0.6 volt. Hence V equal to VV plus VE, which is equal to 0.6 plus 1.4, that is 2 volt. So among the option, the voltage at the output of the OPAMP will be 2 volt, and the feedback will be negative feedback that will be provided through the resistor 1.4 kilo ohm. So D option is the correct answer.